The CRC stands for Centric Reciprocating Compressor. CRC is designed and built based on CR technology, which is Centric Reciprocating Technology, a technology invented, developed, and patented by Otechos of Norway. The air end of CRC is made up of two major sections. One section is the PU, where the actual compression of air takes place, and that compression is done by a pair of coaxially rotating rotors. This is a small pair, and this is a larger pair, which is actually used in the compressors that we are going to talk about today. The second section of the air end is the control unit, where a number of elliptical and circular gears are at work. The use of elliptical gear gives a unique variable angular velocity to the rotation of the rotors, and that's what's actually causing the compression. The rotation produced by the gears is transferred to the process unit by a pair of coaxial shafts. This is the air end of the CRC, which is made of two sections. One section is the control unit, where a number of circular and elliptical gears are at work to produce the variable angular velocity for the rotors, which are inside the process unit here. The process unit is where the actual pressurization of air takes place. The variable angular velocity produced in the CU is transferred to the PU through a pair of coaxial shafts which pass through here. The CU is powered by an electromotor which is coupled to the CU through a shaft here, which goes into the CU. To obtain the desired flow rate for any required pressure, we have to control the rotational speed of the electromotor. The rotational speed of the electromotor is controlled through a variable speed drive. The variable speed drive inputs are coming from a PLC, where the user, by using a user-friendly software, can control the inputs. Through a user-friendly interface, the user can input the desired flow rate for any given pressure, and the PLC will control the variable speed drive. There are a number of instruments connected to the process unit which are fed back into the PLC for control. For further information and instruction, please refer to the CRC user manual. This is the process unit, and this is an intake into the process unit where air is filtered before entering into the process unit. Also, water is injected into the inlet of the process unit, and water does two functions. One is to keep the process cool, and the second is to provide sealing between the rotor and the process unit casing. The process unit casing is also water cooled by circulating water through it. The outlet of the process unit is connected through a system of pipes into the filter, cooling, and into a pressure vessel. The produced compressed air passes through a cyclone to separate any water condensate or liquid condensate, and then it is cooled by passing through a forced draft air cooler. After the air cooler, the compressed air passes through a secondary cyclone to further remove any liquid condensate. It is filtered and finally stored in a pressure vessel for use on demand. CRCs should be installed by qualified technicians